Good morning once again. Today we are going to look into trigonometry grade 11, simplifying trigonometric ratios without using a calculator and also proving identities. The last one will be our general solution. Let's start with 4.1, simplify without using a calculator. Here we are going to use reduction formulas and also using special angles. When we talk about special angles, we are talking about 30 degrees, we are talking about 45 degrees, and we are also talking about 60 degrees. These are the angles that we are using. So 330, for example, it must show one of these angles if possible, if we are doing our reduction correctly. Let's just find a space to do number one. It's tan 330 minus sine 120, and the last part is cos 240. The last part is cos 240. Now let's start. Remember, I said reduction formulas with what? Special angles. So this one can be written as 330 minus 30. 330 minus 30 is still 330, right? I think you get it. 120 is the same as 180 minus 60, and then times 240 is the same as 270 minus 30, right? Now the second part of what we're supposed to do here, we are looking in what is inside the brackets. What is inside the brackets, if you remember very well, our four quadrants here, every angle that is here on the first quadrant is less than 90 degrees, and also let me just say we've got 360 plus here and 90 minus, let me say theta. This side we've got 90 plus and we've got 180 minus. This side we've got 180 plus and 270 minus. This side is 270 plus and 360 minus. So when you check here, 360 minus is on the fourth quadrant. That means this function is on the fourth quadrant, and tan is negative on the fourth quadrant. As we remember, we said here it's all sine, and then here we've got tan, and here we've got what? Cos, which are positive. The other functions are negative. All here are positive. So on the fourth quadrant, tan is negative, so we're going to have minus tan 30 degrees. And then we come to this one. Remember, this already a negative there, but we need to check what is happening here. Minus 180 minus 6, that is on the second quadrant where sine is positive. The positive that comes here, multiply this negative, it continues to be negative. That's correct. Then times 270 minus 30. 270 minus 30 is on the third quadrant, and cos on the third quadrant is negative. Then I'm going to pause a little bit. Remember, 90 degrees and 270, any angle that falls under 90 degrees, 270, as we continue the revolution, then they are going to change cos or sine into a cofunction. So 270 will change cos into sine. But the first thing you do, you first check the quadrant, you write the sign, and then you come to this one. Then now, minus tan 30, we need to check on our calculator what is tan 30. Where is our calculator here? Let's open our calculator and see what is tan 30. Tan 30, it's minus the square root of 3 over 3. What about sine 60? Sine 60 will be minus the square root of 3 over 2 times, I can just put a times, then minus sine 30 is 1 over 2. So we punch this in our calculator. Let's see what are we going to get. We say minus the square root of 3 divided by 3 minus the square root of 3 divided by, no. Let's put this first, square root of 3 divided by 2, and then we multiply this by negative 1 over 2, and the answer is minus the square root of 3 over 12. That is our answer right there. That was number 1. We continue to number 2. What does number 2 say? Let's see the question. Simplify the following to one trigonometric ratio. So most of the time here, people, what we do, I think the very important thing is the sign first. You reduce and you have to be careful about the signs. So I tell my learners that every time you find something like this on theta, put any number that you can put there. For example, if I say I've got sine 180, right, and then minus, I'm gonna put 2 instead of theta, then my answer is positive. It means this one will be positive. And then if I put cos minus 2, like it's given as theta there, the answer also is positive. So it tells you that your answer will be positive. Now it becomes easy because it's either you find 90 or 70 that will change the function, but at least you know the sign of the function, whether it's going to be positive or it's going to be negative. Let's try this one. Simplify the following to one trigonometric ratio. Let's do sine 180 minus theta. It's on the second quadrant, so sine is positive, so you're going to have sine theta. And then this one is on the fourth quadrant, that is cos theta. And then you've got cos 25. There's nothing you can do about that one. Let's just leave it as it is. Sine 90 plus theta, that is on the second quadrant, and sine is positive, but remember there's 90 degrees, so it's going to change to be cos theta. And then sine 425. We're going to make sure here that we get something that will give us something about cos 25. and that is sine 450 minus 25. Remember, on the Cartesian plane, 450, it lies on the 90 degrees somewhere here. It's here also 450. It goes with 90 degrees. That means it's going to change the function into cos. Now, before we can continue here, the next thing that we can do, remember, if we've got functions that divides each other, then they give 1. For example, cos and cos, it's 1. So I will be left with what? I'll be left with sine theta cos 25. Let me write correctly here. Sine theta times cos 25 all over. Let's reduce this one. Remember, I said 450 will change the function into a cofunction, so it's cos instead of sine, and it's on the first quadrant. Remember, it's 450 minus, it's on the first quadrant, so that will be cos 25, and then cos 25 and cos 25, it's 1. That means I am left with the answer that is sine theta, as they have said there, that we are simplifying to find one trigonometric ratio, and that is sine theta right there. The next one, we are looking into 4.3. Let's look into 4.3 quickly. 4.3, we are trying to prove this identity that it is equal to tan theta. So here, the first thing you do, you choose side. So I'm going to deal with the left hand side, which in this case I've got sine theta, then tan, according to identities, remember these are identities, is sine theta over cos theta, right? And then we have cos squared theta all over cos theta minus 1. As I'm looking into this, you can tell that at the end of the day, we are going to have something about cos. So I'm going to change sine square of theta into an identity that is 1 minus cos squared theta. I hope, guys, you are with me. If you remember the identity, the long one, sine squared theta plus cos squared theta, it's equals to 1. Let's move on because of time. Now cos, this cos will take one cos here, so we are going to be left with sine theta minus sine theta times just one cos, and then here we are going to have cos theta minus 1 plus 1 minus cos squared theta, and then we take out a common factor here, which is sine theta. We are left with 1 minus cos theta. We take a common factor at the bottom. Remember, minus 1 and 1 is 0, so we are left with cos theta minus cos squared theta. We take what? Take 1. We take cos theta as a common factor, then we are left with 1 minus cos theta. The content inside the bracket, this one and this one, then it's 1. That means we are left with what? With sine theta over cos theta. Sine theta is sine theta over cos theta. According to identity, this is tan theta. Therefore, you conclude by saying, oh, the left hand side is equals to the right hand side. Let me just finish here for today. I will post another video I'll post another video, or maybe, okay, let me see. I still have time to do the identity and the next one, which is the general solution. Let's do the general solution quickly. This general solution is given in a quadratic formula in this form: ax squared plus bx plus c. Therefore, we are going to use a quadratic formula, meaning a is 6, b is minus 7, and c is minus 3. We substitute directly into our calculator. Let's quickly do that. Remember, our quadratic is minus into minus b, so it's minus into minus 7 right there. I'm going to start with plus and then square root minus 7 squared minus 4, and then the value of a is 6. The value of a is 6, and the value of c is minus 3. Okay, then it's divided by 2 times a, which is 6. Let's see our first answer. So x will be equals to 3 over 2. That's our first answer. Our second answer, I'm just gonna change the plus sign there into a positive sign, into a negative sign, to see the other answer, minus. So we've got minus 1 over 3. Okay, that is minus 1 over 3. So let's do this. I've got, remember the function was cos, right? So cos, the function was cos, so cos x is equal to minus 1 over 3. And the cos x is equals to 3 over 2, right? But if we say cos, shift cos minus 1 over 3, we get no solution on this one. But when we check this one and say shift cos 3 over 2, oh, it says made error. Let me see. Let me close bracket there. Made error. So, okay, the no solution is here. I know 1 is supposed to be a no solution. So the no solution is here, no solution. Let's do this one and see. Shift cos minus 1 over 3. What is the answer? Our ref angle is 70,53. This is our ref angle. Okay. Now, which quadrant is cos negative? It's on the second quadrant where it's 180 minus, and on the third quadrant where it's 180 plus. So x will be equal to our ref angle, which is 180 minus our ref angle plus k 360. K is the element of all integers. That's number 1. So you deal with this, you get the answer. X is equals to 180 plus for fourth. This is third quadrant, and this is second quadrant, and this is third. On the third we say 180 plus 70,53 plus k 360. K is the element of all integers. So these are our two solutions. When you simplify this one, you'll get the solutions, and this is for third quadrant. And that's how we do our general solution. Thank you so much, guys.